Hello everyone, good evening. So here we shall solve from question number 22 onwards. So here it is told in the adjoining figure ABCD is a square. ABCD is a square. A line segment CX cuts AB at X. Cuts AB at X. At the diagonal BD at O, such that angle COD is 80 degree, and OXA, that is X, and the value of X. So this is a square. It means each of these angles are 45 degrees. This is 45, this will be 80 since vertically opposite angles are equal. And so we know that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So X will be equal to 80 plus 45. So that will be equal to 125 degrees. So X equal to 125 degrees. Equal to 125. And here it's told that in a parallelogram ABCD, points M and N have been taken on opposite side AB and CD. Basically says that AM equals to CM, shows that AC and MN bisect each other. Now it is given that M and N are points on the sides AB and CD respectively, AB and CD respectively, in our parallelogram ABCD. In a parallelogram ABCD such that AM equals to CM, and we have to prove that, or we have to show that AC and MN bisect each other. AC and MN bisect each other. So then the proof is, you can say that in triangle AOM and triangle COM, can say that EN equals to AM is given. Angle AOM, that is equal to angle COM, since vertically opposite angles are equal. Vertically opposite angles are equal. Vertically opposite angles are equal. And angle OAM equals to angles OCM. Since why? Since since alternate interior angles are equal, and BB is parallel to CB. So therefore, we can say that triangle AOM is congruent to triangle COM. Right. So we have taken two angles in the non-included side. So we give 5A as rule of congruency. These two triangles are congruent. So therefore, we can say that AO equals to CO and OM equals to OM, right? CBCD. So hence we can say that AC and MN bisect each other at the point O. So therefore, we can say that AC and MN bisect each other. So hence proved. Then here it is told in question number 24 that in the adjoining figure, ABCD is a parallelogram. If P and Q are points on AD and BC respectively, so that AP equals to 1/3 of AD and CP equals to 1/3 of BC, then prove that APCQ is a parallelogram. Now, so it is given that APC2 is a parallelogram where E and Q are points. E and Q are points on sides AD and BC respectively. Thus that AP equals to 1/3 of AD. AP equals to 1/3 of BC. We have to prove that EQCP is a parallelogram. The proof will be that now we will say that AD equals to BC and AD is parallel to BC also. Since we will say, since in parallelogram ABCD, each pair of opposite sides are equal also and parallel also to each other. Each pair of opposite sides are equal and parallel to each other. So therefore, we can say that 1/3 of AD will be equal to 1/3 of BC also. 1/3 of AD means AP equals to CQ. And obviously AP is parallel to CQ. Since why AP is along AD only and CQ is also along CQ. So I can say that so now therefore I can say that therefore in quadrilateral AQCP, quadrilateral AQCP, AP is parallel to CQ, AP is parallel to CQ and AP equals to CQ. AP equals to CQ, which has been proved above, has been proved above. So I can say I can say that AQCP is a parallelogram. Since one pair of opposite sides, are equal and parallel. One pair of opposite sides are parallel and equal. In quadrilateral AQCP. So hence AQCP should be a parallelogram. So hence proved. Then in question number 25, it is told in the adjoining figure ABCD is a parallelogram whose diagonals intersect each other at O. Whose diagonals intersect each other at O. Diagonals intersect each other at O. A line segment TOF is drawn to meet AB at E and DC at F and prove that OE equals to OF. OE equals to OF. you have to write what is given. It is given that ABCD is a parallelogram whose diagonals AC and BD intersect at O. Then a line segment VOF is drawn. VOF is drawn to meet AB at E and DC at F. AB at E and DC at F. We have to prove that OE equals to OF. OE equals to OF. The proof is given as as we can say that OA equals to OC. OA equals to OC. And OB equals to OD. Since in a parallelogram, the diagonals always bisect each other. Diagonals bisect each other. So now in triangle OEB and OFD, you can say that angle EOB that is equal to angle FOD. Since vertically opposite angles are equal, and just the FDO, the angle FDO that is equal to angle EBO. Since alternate angles are equal, since alternate interior angles are equal, since AP is parallel to DC. Obviously, it's BD is the transversal. And obviously we can see that. So we have shown these two angles are equal, and these two angles are equal. And so OB equals to OD. OB equals to OD. Since BD, since AC bisects BD at the point O. So therefore, we can say that by ASA rule, since this side is included, we have taken two angles and the included side. So therefore, I can say triangle OEB is congruent to triangle OFD by ASA rule of congruency. The angle side angle rule of congruency. The ASA rule of congruency. ASA rule of congruency. So therefore, we can say that OE equals to OF. OE equals to OF by CPCT. OE equals to OF by CPCT. So hence proved. And here it is told angle between two altitudes of a parallelogram through the vertex of an optic angle of the parallelogram is 60 degrees. Find the angles of the parallelogram. The angle between two altitudes of a parallelogram through the vertex of an optic angle. Angle between two altitudes. So if I draw an altitude, let's say this is A, B, C, D. So one altitude from this optic angle is this. One altitude from this optic angle. This is E, this is F. So one altitude I have drawn from point D. Since here B and D are optic angles of the parallelogram. So the angle between these two altitudes, that is 60 degrees. Then find the angles of the parallelogram. So hence we can see that this is 60 degrees, so this is 90, so this should be 30 degree. Since the angle sum, since by using the angle sum property of this triangle, let's call this point as O. So in triangle OAB is a right angle, so the sum of three angles would be 180 degrees. So it means this angle has to be 30 degrees. Now in triangle similarly ABF, this is a right angle, this is 60 degrees, so this is 30 degrees. So this angle also, angle A should be 60 degrees. So it means angle A and angle C should be equal since ABCD is a parallelogram. So angle, therefore I can say angle A equals to angle B. Yeah, that is, so angle A equals to angle C. So A equals to angle C, which is equal to 180 minus 90 plus 180 minus 90 plus 30. That's why these two angles sum is 90 and 30. So that would be equal to 180 minus 120, that is equal to 60 degrees. So this angle is also 60 degrees. Now these two angles are being obtained. Now we know that the sum of the co-interior angles is 180. So it means this angle should be 120 degrees. 120 degrees. So this angle also should be 150 degrees. Therefore, I can say that the angles of the parallelogram are 60 degree, then 120 degrees, 60 degree, then 120 degree, then again 60 degree, then 120 degree. So this is the answer. Then in this question number 27, it is told that ABCD is a rhombus. ABCD is a rhombus in which the altitude from D, ABCD is a rhombus, in which the altitude from D bisects AB. Altitude from D bisects AB. So this is B, suppose. Then, so this is equal to this. Then find the angles of the rhombus. So you know that all these sides are equal. Rhombus and find the angles of the rhombus. Now AB length, if I take it as x, then this is also x, also x. Now AE equals to AEB, that is equal to half of AB. Since it is given that E is the since it is told that DE is perpendicular to AB and E DE bisect AB. DE bisects AB. So therefore, I can say that AE will be equal to x by 2. This length is x by 2. Therefore, this angle now to join this D and B, this is of x. Now you can see that in triangle ADE and triangle BDE, you can see that at angle AED, that is equal to angle BED, which is equal to 180 degree, no, which is equal to 90 degree. Since obviously since DE is perpendicular to AD, and obviously DE is common side, DE is common side, and AE equals to BE, AE equals to DE, since y both are equal to x by 3 is AB by 2. Here we take, here we have taken, let's say AB equals to AD is equal to BC is equal to CB is equal to X. Suppose since you can say since ABCD is a rhombus, so all its sides are equal in length. So this is your x by 2. So therefore we can see that triangle ADE is congruent to triangle BDE. ADE is congruent to triangle BDE by angle side angle, means A is a rule. This is side angle and side angle and side. So by SIS rule of congruency. SIS rule of congruency, these two triangles are congruent. So now therefore we can say that AD equals to BD by CBSE. AD and BD are same. So this is also length x, this is also length x, this is also length x. So here each angle is 60 degree. 60, this is 60, this is also 60 degree. That means this is 60, so the opposite angles are equal. This should be also 60 only. And so, and opposite sides are parallel, and the sum of co-interior angles is 180 degrees. So this angle is 120 degrees, and this angle is again 120 degrees. Or we can say that triangle ADB is isosceles. From here only you can say, therefore triangle ADB is isosceles. So I can say that angle DAD, and also we can see that all the sides are equal here. AB equals to AD. So therefore we can also say AD equals to BD, which is equal to AB also. So this is also an equilateral triangle. This is also an equilateral angle. So this angle is also 120 degrees. So therefore I can say that therefore the angles in the rhombus are angle A, that is equal to angle C, which is equal to 60 degree, and angle P that is equal to angle D. Angle B that is equal to angle D, which is equal to 120 degrees. So these are the required angles in the rhombus, ABCD. So hope all of you understood the solutions of all these questions till question number 27. Still any doubts if you have, please write that in the comments. We shall obviously clarify them. So thank you everyone. Bye.